Hello, so the lesson I wanted to go over today was use substitution because this was one of the subjects I struggled with for the last exam, and I thought maybe creating a lesson might help me, so let's go ahead and get started. These are the rules that the professor is going to give you, and they honestly look pretty daunting, but I promise you it's so simple. All you're really going to do is find the inside part, then you're going to compute du, and then you're going to translate all your x's into u's. Once you do that, you're going to find the u integral, and finally substitute everything back to the way it was. It sounds intimidating, but let's get into an example so we can go ahead and get started. So this is going to be our formula, and more in depth, like I mentioned on the last slide, you're going to find your inside function and you're going to call it u. So let's find something that's either in the parentheses, an exponent, and look, we have something in the parentheses, so that's going to be u. U is going to be 3x squared plus 4. Alright, so just a quick reminder of what's actually considered the inside function. It's going to be anything that's in a parentheses inside a radical, the exponent of e, or a denominator. We have to find the derivative of u, and that will be called du over dx. So let's write that down, and we're going to have it equal. So the derivative of u is going to be 6x, because 3 times 2 equals 6, and the x is still there. Next, you're going to multiply both sides by dx in order to get du by itself. And the answer to that is going to be 6x dx. Now that we found all the u terms, we're going to move on to the next step, and that is rewriting our original integral. And we're going to rewrite it a little different. I'm going to go ahead and write the beginning part so you can see how I'm going to start it, and then I'll explain as to why I wrote it like that in just a second. So we're going to write 3x squared plus 4 to the 4th times 6x dx. And the reason we're going to do that is because if you look at our u terms, it's a lot simpler and it's a lot easier to match it once we plug in the u. So we're going to go ahead and replace the 3x squared plus 4. That's going to be our first term. That's going to be your second term. Now let's just take a quick look at our u terms and our new integral that we rewrote, and let's try to match it up. So 3x squared plus 4 is going to be u, and then the 4th power is still going to be there, and du equals 6x dx, so that's simply du. And once you've written it out, now we can move on to the 7th step, and from here we're going to find the antiderivative of u to the 4th times du. The antiderivative of u to the 4th is going to be u to the 5th power over 5 plus c. We are down to the last step, and that is pretty much plugging everything back in so that we can have our answer. So pretty much it's going to be 3x squared plus 4 to the 5th over 5 and plus c. You never ever forget the plus c. One good thing about doing these is that you can actually check yourself by taking the derivative of your answer to check. Let's go ahead and check our answer. But before I get started, let me write the answer that we got down so I don't have to zoom out. So that's going to be 3x squared plus 4 to the 5th over 5. And you never forget the c, plus c. But I think this is so cool that you can check yourself, because at the end of the day, derivatives is my favorite thing about calculus. So why not go ahead and take the time to check yourself, you know? Might as well. An extra point on the exam. So let's go ahead and get started on finding the derivative of this. The derivative of this would be 5 times 3x squared plus 4 to the 4th, because we're using the chain rule, over 5 plus c. Oops, actually it's not plus c, it's going to be times 6x. And then from there, we're going to cancel it out, and we still end up with what we started with. And I just think that's so cool that you can check yourself and make sure you got the right answer, because it's going to lead you back to the original problem. Now that we have that figured out, let's go ahead and move on to example 2. Our problem is going to be 1 over 4x plus 1 to the 3rd dx. Our first step is going to find the inside. Luckily for us, it's within the parentheses and the denominator, so it's really easy to find. It's going to be the 4x plus 1. So let's go ahead and write that down. U equals 4x plus 1. Now we're going to find the derivative of that, and that's going to be du. It's just going to be 4 and of course we have to have the dx, but since dx is not by itself yet, we have to divide it by the 4, and then it's going to be 1/4 du equals dx. Now that we have all of our terms, we can rewrite our integral. The u will now replace the denominator, and instead of putting 4x plus 1, we're just going to put u. It's going to be 1 over u to the 3rd times dx, and if we look down here, dx is going to equal 1/4 times du. From this part, we're going to go ahead and rewrite it one more time so it's easier for us to solve. It's going to be 1 over 4, and then u to the negative 3 times du. Now that we've successfully rewritten our original integral with the u substitutions, we're going to move on and we're going to find the antiderivative to our new integral. So it's going to be 1/4 times u to the negative 2, because we're adding 1, over negative 2, plus c. And then we're going to go ahead and simplify that just a little bit more since we can. So now we're going to multiply the 1/4 throughout. The answer will be negative 1 over 8u squared plus c. Now that we have our final antiderivative fully simplified, let's move on to the last step, and that's going to be negative 1 over 8 times 4x plus 1 squared, because we're plugging in our original terms one last time. And that's how you solve example 2. Yay! On to the next problem. So I wanted to choose E because even though E's are supposedly simple when it comes to derivatives, it's the fact that they're so simple that makes it complicated for me personally. The problem is going to be e to the 10x over x squared. So luckily there's only one e here, and the exponent of it is going to be 10x. So 10x is going to be our inside function, and that's going to be our u. Now that we found the inside function, we know that u is going to be 10 over x. And then du is going to be negative 10 over x squared times dx. We still have to get dx by itself, so we're going to multiply by the reciprocal, which is going to be negative 1 over 10 times du equals 1 over x squared times dx. Now that we know all of our u terms, we're going to rewrite the integral as we have been. It's going to be e to the 10 over x times 1 over x squared times dx. From here, we're going to plug in all of our u terms. It's now going to be e to the u times negative 1/10 times du. In order to use the u substitution more smoothly, we're going to rewrite it one more time. We're going to put the 1/10 in the beginning, e to the u times du. And then now we're going to finally solve for it. This is going to be negative 1/10 e to the u plus c. Now we have our new integral. We're going to use that integral and plug in our original terms back. It's going to be negative 1 over 10 times e to the 10 over x plus c, and that's going to be our answer. On to our last example. Our last example is going to be the square root of w plus 5 times dw. And for our inside rules, it's going to be what's inside the radical. U equals w plus 5. We're going to find the derivative of that, and that's just going to be dw. And then, luckily for this one, that's it. It's pretty simple. Let's move on to the next step of rewriting the original integral. It's going to be the square root of u times du equals u to the 1/2 times du, and pretty much all we're doing there is rewriting it so it's easier for us to solve. Now we're going to find the antiderivative, and this is a simplified answer of it. It's going to be 2 over 3 times u to the 3 over 2 plus c. From there, we're going to do our last and final step and plug in all of our u original terms. So it's going to be 2 to the 3rd times w plus 5 to the 3 over 2 plus c, and that is it for our last example. And then, before you guys go, let's review the rules one more time. Remember, it's important to find the inside function and use the derivative rules to find u and du over dx. We then have to rewrite the original integral, plug in the u terms, find the antiderivative, and replace u terms with the derivatives from step 1. Other than that, thank you for viewing, and I hope you enjoyed. Okay, bye.